Okay, let us continue to the last method for the line integral, which is we call it that as method number 8. Okay, method number 8, and this is, we call it, is a very famous and one of the very prominent method in the what you call line integral calculation. We call this as a green theorem. Okay, the green theorem, theorem for the 2D. Okay, I'm saying 2D because this is there is a father for this theorem. There is a father for this theorem. We call it that as a Stokes theorem. This is a son. The father is a Stokes theorem. Therefore, green theorem is a for the 2D. The father is a for the 3D, to calculate the 3D. Okay, now what can we do now? Practically, in this case, we call it this as a method. It will take around few minutes to close this whole topic for the line integral anyway. Okay, now this method number 8, I will call it F. Simple, just that the green theorem works based on F is closed okay, F is in a closed loop in D as a domain, similar to the earlier logics that we use. It's actually F is not in the closed loop. F is in the closed loop D. It must be in the closed loop region. And number 2, F is not conservative. Okay, that should not be a conservative. That means now we are creating one simple logic in this. When we say let if it is not a conservative but is a closed loop, then we call it this is a green theorem. Okay, it's opposite to whatever that we learned before, but now we see how the logics really works for this. Okay, let F equals to Pi Qj, or we can choose F1, F2, or sorry. Okay, this is common. That's why I'm introducing P and Q. For all the books, they will use as a standard P and Q. Therefore, I'm using P and Q. You may say, can I use F1, F2? Yes, you can proceed. If F is not conservative, okay, conservative, then del F, that means del the gradient of this is not exact. That's what our conclusion is, right? Okay, earlier we say if it is what you call conservative, there must exist a potential function. The gradient of the potential function must be equivalent to the F. Okay, now if this is the scenario, okay, if this is the scenario, we know it's a non-exact. Therefore, when pick this P and Q, remember to this, I'm trying to write again. Please try to understand what I'm trying to say here. Okay, okay, maybe it's like this. Okay, earlier we see if it is a conservative, it's equivalent to that. If it is a not conservative, therefore it's not conservative. That's it. Okay, now we just write this again. Qj is equivalent to the things that we are trying to explain here. Therefore, if it is not a conservative, you know that we can write this del F to the del xi, del F to the del yj. Then we know this is represented by this what you call P is equivalent to del F del x, and Q is del F del y. Then I'm saying it's not exact. You know, we already highlighted this as not exact. Therefore, if it is not exact, I may call it del P del Y, whereby del 2 to the del F del Y to the del X, okay, is not equal. Let me put it this first, del Q to the del X. Therefore, it's a something del 2 to the del F del X to del Y. Therefore, is not same. We are saying in which scenario it will be not same. Means in an easy sense, we are trying to say del Q del X not same. Or this is a 1, or we are saying, you see, there is a one case which is not possible. But we'll learn according to the square root rules, this must be same. But how can this one is not same? Is it possible? Can be not same. In which scenario it become not same? Is if it is not continuous. If not continuous, okay, then immediately we will say this is not same. But in this scenario, we are trying to highlight this as something like that, just to give you, okay, because it's not complying the Clay Root's theorem. But Clay Root theorems, it has a few conditions to fulfill if it is this one to be same. But don't bother so much about this, but this is very important for us to work with. Therefore, if it is not same, this one we will call it del P, okay, del P del Y minus, you can choose whatever, del Q to the del X not same. Can you see that? Okay, I can bring it this not equals to 0. Okay, or you may say, can I write this way, del Q to the del X, okay, I bring it that to the del P to the del Y not equals to 0. Yes, it's up to you to choose which option you like. Therefore, it's a point of view that we are trying to create out of this. Okay, whether the work is basically, this is a surface flow. We're going to analyze the surface flow of that, whether the flow is coming out or in. Basically, that's what we are going to use this for the Stokes later. Okay, the charge is coming out or going inside. Therefore, now I'm going to write for you the formula for the theorem. Okay, what is the formula for the theorem? The formula for the theorem, let me write here on the top. Later I'll elaborate on this. The formula for this theorem, if it is this, not same, if it is a conservative, then I say not exact, and it must be a closed loop. Can I write that in a different paper? Okay, suppose I should take some space there. But anyway, I just elaborate on this, which is, okay, is closed loop. It's very important. Closed loop of f dot dr equals to negative, okay, del p del y del q del x, which is dA. This is referred to the area. Okay, area. This is double equation. Therefore, you can see this is a R. I is a constant, but anyway, we refer to the region. R stands for the region. The means is a work. Okay, the work will be calculated based on this one region. Okay, then if you don't get it here, I just say there is a closed loop, then is moving. Maybe this could be the point that we are looking at. We take the area, okay, the area of F. You see the ball rolling on this, okay. You calculate for the closed loop, you can calculate the whole the work. That means the difference, okay, the difference of non-exactness, okay, we use that to calculate the area, then automatically we manage to calculate the the work. Okay. In this case, Let me show you the simple example, one of the example that is a very important example I feel. Okay, now I can give you some scenario whereby, okay, we take it a one case example. Let y equals to 2x, and okay, I just draw first. This is the drawing first, because let me sketch this. This is a closed loop, C1, C2, C3, okay, C3, and and we know this is not a conservative. Okay, we can prove this conservative, whether it's a conservative or not conservative, based on the the logic that we are trying to say. Find the work, find the works. I keep it to all simple one. If find the work if f equals to 2x plus y, is it correct to address that? Wait, just to the just I wanted to make sure this. Okay, plus I and plus 3x minus 3yj. This is a correct j. Okay, if this is the force, first we need to identify whether this one is exact or not. Okay, it's a 2. Okay, this is a 2y. Okay, now when you say find the work if f equals to 2x plus y, I and this. Okay, now if this is the case, can we verify whether this is conservative or not? Okay, this is a conservative or not. The first question to verify this is whether it's a conservative, not a conservative, we choose there are two options to handle this problem. Maybe I write the first option 1. Instead we use whole thing. We know this is a closed loop, but let me use this. This is, we call it as a C1, C2, right? Okay, therefore the whole circle of the C is equivalent to C1 plus C2 plus C3. Okay, is it correct, right? And the whole work can be calculated based on 1, 2, 3. Okay, then let me choose one by one. I show you some of the work very fast, because to help you to understand the process can be calculated in a various way. Okay, one of the way that I can start calculating the C1. For the C1, if I wanted to calculate, as you all know, okay, if this is the equation, seems this one is a 1 and 2. If I fix this is a 1 and this is a 2, therefore this is 1. I make it an easy one question. Later similar questions will come out. We will if we got a time, then we will do some tutorials later, but okay, hopefully the time is a matter here. Okay, now for the C1, y equals to 0 and dy equals to 0, and we already learned what we call to use the method number 2, right? Method number 2 saying this is sometime you tend to forget. Dr we define as a dx I dy, okay, dyj plus dzk. Okay, when we times with this, therefore in order to get work which is f times with the dr, where we will get f dx f1 f2. This is, we call it f1, this is f2, okay, f2 dy, okay, f1 f dy, therefore, and plus f3 if there is f3 lah, okay, dz. Okay, now with this, can I calculate for, since this is a 2D base, we know this is a 2D base, therefore dzk is not there. It will influence the calculations. Therefore dx, dy, we just match with this. The calculation will be for the case here, dy, since is a 0, we no need to calculate as well. Therefore the f here, f1, 2x plus y dx. We know y is a 0, therefore the calculation, the solutions, we may get it c1 as a, what is the solution? c1 is a 2x, what is the range here? 1 to the 0, okay, therefore it's a 2x2 2, then you get a 1 as your solution. Okay, quick. What about c2? Okay, c2, we are applying the same, but I'm not going to repeat the work again. This is the same work, you can see here, there is the same work here. The work basically is influencing the whole thing here, and x equals to 1, because I calculated earlier, right, dx is a 0. Therefore if this is the scenario, we use the same method here, but dx is a 0, we only able to calculate the side. Therefore we will get for the c2, this is a c1, I worried whether I am seeing the correct one. Okay, c2, therefore we get a 2 to the 0, 3 minus 2y equals to dy. Therefore when you solve it, this part, you get a 3y, y2, 2 over to the 0 equals to 0, okay, you get a 2, okay, you get a 2, okay, done. Okay, what about c3? What about c3? To calculate the c3, can I use one of the space here, because it's not safe, because I wanted to make sure that you all can see what is going on here. Okay, this one, where can I use? Okay, still we are in the option. Okay, I use this space here. I don't know whether it's enough or not, I'm not sure. Let me try. Okay, because it's easy for me to show you the c3. Okay, what is important here? c3 is a y equals to 2x, therefore dy equals to 2 dx. Okay, can. Okay, now for the c3, the work for the c3 equals to 2x plus y dx plus 3x minus 3y dy. Okay, we need to substitute. This is a lengthy one, of course. Okay, we just substitute again. We wanted to base on x or y, it's up to you again. This time I leave it to you. Okay, but this time I'm going to use x. I'm going to use x base, therefore 1 to the 0. I use this as a 2x, y is a 2x dx, and plus 3x, 2 by 2y is a 4x, which is dy is a 2 dx. Okay, therefore what I'll get here, I get a 1 to the 0, 4x, okay, dx. This one is a minus, okay, you can solve this is a 1, okay, 1x, therefore 2x lah. Okay, I hope that you can solve this part. Okay, this part, this is a 2x, here, okay, is times with the dx. Okay, now you can combine and you can do it. The solution that you will get it here is 2x squared over 2x squared. Then you will, once you solve it, you will get 7 over 2. I'm not wrong. Okay, you try to solve this part again. Okay, let me solve this anyway. This is a 2x here, 2x 2 to 2 to 2. I made a mistake here, suppose something wrong seems. But I got here different answer. Wait, let me made somewhere I made a mistakes. X, okay, this is negative 2, yes, is correct. 2y is a 4y, 4x, and supposed to be 4 to minus, then I get a 1. Okay. Okay, then this will be the answer that I am getting here is a 1 over 2. Okay, 1 over 2. Okay, I getting 1 over 2. The combination that I may get it here 1 over 2, is it a correct answer? Let me see. Combine this, I get, suppose it's a 3 over half. Is it 3 over half? No, answer is a 2. How can that I made a mistake here, seems. Okay, that means something. It's a simple one anyway. Sorry if I overlook sometime, I just, okay, this is a 2. Okay, later I get back to this. Okay, because I worried later battery will be one of the issue that I need to resolve it, because every time I spend some time, Okay, I'll get back to this. Anyway, you solve this. Okay, I just wanted to introduce these logics here. Y is equals to 0 and dy, then this is 1 is correct actually. Okay, this one both no issues. Okay, but the C3, suppose I should get negative 1, but am I getting negative 1 here? No. Why I cannot get negative 1? Oh, one of the reason a big blunder that I made here. Can you see where is the mistake of mind? Very beautiful problem actually. You see the arrow, I forgot the arrow at all. Okay, I forgot the arrow. The arrow is moving from top to the bottom. It's not climbing up. Okay, it's a good learning. Okay, it's a good one, because at least I managed to capture this part at this moment because of these mistakes, you see. Okay, because of this, this one must reverse in the order. It must be reversed in the order. It should be like that, 0 to 1. It cannot be, okay, because it's directing from here, it's coming like that. Okay, therefore it should be 0 to 1. Okay, this is one of the very helpful information that I think is right time lah. On right time it's fall on the give us some illuminations lah, I may say. Okay, therefore this is a 1, 0 to 1. Okay, therefore the logics that we are trying to solve it here is not half. We get a negative 1 as a solution. Okay, I don't know why just now I put half here. Sorry, this is 2, then I just enter, then I get a negative 1 as my solution. Okay, can I see I made a corrections then? Okay, lucky I managed to detect that problem, because see I overlooked. Sometime when we overlooked here when I start teaching this part. Okay, just I'm creating this because I don't have nodes in this particular space, just because I just create for you to help you to see they could be a various way to solve it. It's not a one way to see the problem, see. Therefore this is correct. Therefore you see when I combine here, okay, the work for this work C1 plus work C2 plus work C3, suppose you get a 2 as your answer, okay, 2 as your answer combination. Okay, now with that, this is a way that you see, very extensive way to do this, right? Now I'm going to show you to solve the similar problem for the looping. We're going to use a green theorem to solve this. Okay, we're going to use the green theorem to solve this problem. Okay, now let me show you how to solve this problem. See, using a green. Okay, to use the green is a very easy and straightforward to use it. Therefore I call it this as a option 2 using green. Again, you cannot use for all the cases. Student always think, okay, I can use a green theorem for every cases. No, the green theorem only applicable for the loop. Okay, it must be a closed loop. If it is not a closed loop, you cannot use that. Okay, you cannot use green theorem. Okay, we use a green theorem whereby we know our F1 and F2, right? We know our F1, F2. Just let me write. The F is 2x plus yi, 3x minus 2yj. Okay, this is F2, F1. Or can I say PQ? Okay, let me stick to the PQ because the formula I given you is something to do with that. Okay, P equals to 2x plus y. Therefore, Q is 3x 2y. What is del P? Del y. Because it's x, right? We need to use the opposite to that. Which can I do the del y for the del P del y? I get the answer here is 1. Okay, del Q del x, the answer is 3. Okay, if it is the same, is a conservative. If it is not the same, this is not a conservative, right? Therefore, how to calculate the W? The W can be calculated based on del. Okay, the question is which one to be used. There are formula. Am I given a formula? Yes. The formula works on a negative dp dq minus this area, right? This is the formula that I introduced to you. Some of you may ask, sir, I don't like the negative, put it outside. Can I use this way? Okay, can I just bring inside and say del q del x minus, okay, minus, can I use that? Okay, the idea is this. Okay, del p del y for the case dA can. Okay, what is the difference? Okay, the difference is, as I say, perspective. Okay, the perspective is whether you are looking from which point of view. Okay, which point of view? Okay, inside or outside. It's a detail of inflow or outflow. Okay, later I will explain to you this in detail, whether how to see this problem. Okay, whether it's inflow or outflow. Okay, I'll tell you the logics, what the arrow actually is, whether clockwise or anti-clockwise later. Okay, let us solve this first. Okay, I show you this one. Okay, can I choose this to be negative here? Okay, I stick to the same formula, dp del p del y. Okay, okay, this one is del q del x dA. Okay. Okay, with that, can I start how to do it this. Okay, the area, what are you talking about here? The area is, I am referring to this area. Can I calculate the area here? Can. Let me use both. Okay, we on this is a double integral, and area is basically we are referring to dx dy. Okay, we use a dx dy, or depends whether you wanted to change it or not. Okay, again I repeat to you, if some of you may ask, can I use this dq dx minus dp dy? Can. Okay, can. You can use either one of this, but later I'll tell you what is the idea of this. Okay, when I use this, just it is a 1 minus 3 minus, I'll get a positive, right? Therefore, okay, what is the equation that I need to use for the dx dy, where this is a dq dy, this is a 2. Can I make it a 2? Okay, this is a 2. I'm using this one, I'm not using the top one. Okay, still same. Okay, 1 minus 2. Okay, what is the formula that I can use to calculate this? Okay, how to calculate this area of this portion? Okay, now can I place my eye here? Can I place my eye here? If I place my eye, this is a dx, right? 1 to the 0. Okay, what about dy? Okay, this is a 1 to 0. My place, I'm placing my eye here for the dx. Okay, what about the y? Y equals to what? Y equals to what? Just to finish this part, looking at this, can you tell what is y? Can I choose to say this is a, remember, if I choose this as a 2 to 0, I'm taking the whole area, you know? Cannot. This is not, I'm calculating the whole area. I supposed to use this equation, because this equation control the y. Therefore, the equation is 2x and down to the 0. Okay, therefore, can I solve this? Yes, I can solve. And the solutions, once you solve this problem, you able to handle the problem with this 2y, then you just place here, okay, 1 to the 0. Actually, I want to show you one more example, good example, that which will play another important role in this particular case. Okay, if this is the case, you can see there is okay, 2 taken out. Okay, 2 taken out, and this over here, this portions here, I solve 2 dy actually is a dx, sorry, dy, I just with the 0 with the dx. Okay, then you solve that 2, 1 to the 0 for x, okay, with the dx. Okay, then for x2 to 4 0. Suppose I should get the same results. Why am I getting the different results here? 2 to y, 2x. Suppose I should get a 4 here. Wait, x2 over 2, I get a 2. For x1, I get a 4 as my answer. Just now I got the 2 as my answer, right? Solution. Let me see whether am I correct here. Again, why am I stuck here? Suppose am I making a mistakes here? Okay, this is 2 correct. Okay, 2 y, then I get a 2y, 2. Okay, 1. Hey, where are you? Okay, this is okay. where am I made mistakes here? 2x. Okay, this 2 taken out. Y 2x. 2x is a 4x. Then x2. Okay, this 2 over 2. Sorry, this cannot be a 4, right? Always I'm making a mistakes here. Okay, 2, then yes, this is 2. Why lah? Simple things are sometimes, because when I recording here, when I'm making a recording, then I just see that, because I want to be a little bit spontaneous. That's why I cannot see certain things quickly, because I'm looking at the from camera to see whether okay, this is a 2 anyway. Okay, when you solve this, then you get a 2 as your solution. Yes, correct. We made a simple things. You see, sometimes we just get stuck here. Okay, with that we already concluded, but I want to highlight to you one important things here. Okay, very important things which is very helpful to you. Since a, we wanted to calculate the a. Okay, since this is a constant. Okay, since this is a constant, nothing involved here. Okay, when I try to bring this out, can you see this portion alone, you look at this carefully, you will get some interesting point of view. When I try to taking out of this 1 to the 0, 2x to the 0, this is a dA, right? Okay, this is a dA. If it is a dA is a area, right? This is actually is a what? We are calculating the whole area. Can you see that? This is we are taking, this is the ghost coming out. You see, there is a no ghost taken out. This is actually calculating the whole area. Therefore, can I calculate this? Okay, can I calculate this? Easy, right? I can use the simple area calculations, okay, of the rectangle. See, calculate the half height and length, which is a 2 times with the 1. 2 times with the 1. Okay, this is a rectangle calculation. See, I can straight away I can calculate and give you this. But remember, if this one is not a constant, you won't be able to use this method. Okay, it's actually what I'm trying to say is a 2 times rectangle. It's not a rectangle, sorry, triangle, area of triangle of closed looped triangle, closed loop triangle. Okay, triangle. Therefore, we can use this kind of method also to calculate the the area, but only one condition. Again, I strongly, this must be constant. Once you're taken out, then actually you're calculating the whole area. You must be a dy dx. We already learned this in a double integral. I will repeat this later. Okay, when I start teaching, the next class will be something to do with this. I'm going to teach you the double integral and triple integral in detail before I move into the surface. Okay, is it okay? We have done the green theorem. Okay, so far how many methods you learn? You learn 8 method. Okay, you learn 8 method. You want me to just summarize the whole, but I cannot say 8 method, 8 different various way to solve the problem. Okay, to solve the problem, 8 different various way to solve the problem. As long as you can solve the problem, you can it's a little bit blur, I don't know why. Okay, the camera, okay, automatically it's okay. Therefore, I wanted to emphasize few things. Just quick line integral, quick capture of this. Okay, we learned something in a method 1. Now I'm not going to write the whole thing. Just work 1 is f times with the s. Both are vectors. Okay, but I already told you work is actually scalar value. Okay, in method number 2 we learned something to do with the FDR. Okay, FDR for the curve. For the curve, this is for the curve where which is for the RT. It could be XT I, XYT I, J, Z T K. Okay. In a third rule we combine together. Okay, we combine together the magnitude here. We combine the FDR with the this F1. We're taking the F since let F be okay. Can I say F1 I